So we know the endocrine system is regulatory. It's going to keep, it's going to allow your body to communicate with other parts of your body to coordinate responses. Basically, hormones are controlled primarily through what's known as negative feedback. You guys should have learned negative feedback in Bio 101 as a way of controlling the biochemical pathways. In brief, negative feedback is where a product of a system goes back and interferes with the system. The way I always describe it is, think of, there's a show on like TLC, it's like 21 and Counting. It was just a family that has a ton of kids. You guys know what I'm talking about? Yeah, them. They've got a ton of kids. So imagine, if you will, you got the mom and in case you didn't know, the way this whole thing works is a mom and a dad come together, they produce an offspring, the offspring grows, the offspring becomes an adult, and then they themselves will produce offspring. Now, this pathway for this particular family goes, mom and dad mate, baby is born, baby grows, becomes adult. If a later stage in the pathway comes back to interfere with an earlier stage, that's going to be negative feedback. So that would be the kid that became an adult gets birth control and slips it to the mom. So now you have a system that's being regulated from the end product. Does that make sense? It's going back and interfering with the original start point. That doesn't stop the first set of kids from being born. They're still born. It's just, it limits the total amount that can happen. And we're going to see a few examples of that today, of going back and interfering with an earlier stage in the cycle. So rising levels of hormone will end up inhibiting further levels of release. So if we have product A, substance A goes through an enzymatic reaction to become substance B, goes through an enzymatic reaction to become substance C, and substance C happens to inhibit enzyme A. So this process is self-limiting. You begin to produce a product, and that product slows down the process, so you're not making too much of it. This is primarily how your body controls the amount of material it's either making or consuming. So these hormones then get used to maintain homeostasis, to maintain a certain level. When you get too many products being created, those products end up serving as a stop, as a break on an earlier phase in the cycle to slow down the creation of those products. You have to maintain a normal body temperature. If you don't, you die. You got a few ways of doing that. Let's say you've got normal body temperature and your body temperature decreases. It's a cold day, like it was, a week and a half ago. Your body temperature decreases, your hormones are released that cause your blood vessels to get narrow. That leads your, so you're not pumping as much blood to the outside of your skin. You'll notice that you get a little bit paler when you're cold because your blood is trying to get conserved toward the core. You start to shiver, which generates heat. So your body begins to warm up. Eventually, you have to stop shivering and your blood vessels open up because you're back at normal body temperature. Otherwise, you start to heat up. Body temperature increases. So blood vessels widen. You might flush in order to get more blood vessels to your cheeks where they'll cool off faster. You start to sweat in order to decrease the amount of heat that your body's got. It's going to be radiated out. And then that brings you back to normal body temperature. So you're constantly adjusting yourself to maintain a central normal point. Antidiuretic hormone. So this is a very specific case where we're going to look at maintaining water levels in the body. Is produced in the hypothalamus, so one of those main gland locations. And it's going to tell your kidneys, reabsorb water. Water, as you guys know from our many, many discussions of getting organisms onto land, it was critical because we're no longer surrounded by ocean water. We have to maintain an internal level of water in our bodies. So you have to regulate those levels. Too much water, not good. Too little water, not good. You have to have just right. It's like the Goldilocks of water. So we have aldosterone, which is a hormone produced by the adrenal cortex, is going to enhance sodium absorption. All right, so basically you have a hormone that says cells absorb sodium. We're increasing the amount of sodium in the cells. Do you guys remember osmosis? If you have more sodium in the cells than outside, which way is the water going to go? So there's lots and lots of sodium inside the cell, high solute inside, low solute outside, lots of water on the outside. Yeah, the water comes into the cells. You're going to get reabsorbed. So far, so good. So that's how you get water out of your bloodstream and into your cells. Conversely, what if you have too much water in your cells? Well, then you raise the level of solute outside of the cells in the extracellular liquid. You've got more solute, more ions out there, so water will leave the cells. That's going to be one of those examples of humoral hormone regulation or hormone production. You also need to, we use hormones to regulate reproduction. You've got these follicle stimulating hormones and luteinizing hormones that are produced in the pituitary gland, sort of up by the base of the brain. The follicle stimulating hormone will tell the sperm cells to mature. So they're like, hey, time to grow up, getting ready to move out. In females, it stimulates the maturation of the egg cells. Luteinizing hormone, on the other hand, is going to stimulate the production of estrogen and progesterone. So you're going to make more hormones. So luteinizing hormone says, make more hormones. What kind of hormonal regulation is that? Where a hormone triggers the production of other hormones. Hormonal, right. So we get estrogen, we get progesterone being built. They're going to trigger other reactions to occur. I don't need you to know step by step what happens in each, with each hormone. What I need you to see is one hormone triggers another hormone that triggers another hormone that triggers an effect. You've got a major hormone being produced that triggers several other hormones to start being made that then causes the cells to do something. Whether it's the eggs to mature or the sperm to mature or say the development of secondary sex characteristics. So we're not even just completely occurring in the gonads, we're occurring all throughout the body. Hormones are involved in the regulation of digestion. And probably the most common example of this is insulin. So I'm going to go into a little bit more depth on insulin, only because it is so commonly understood and a lot of people have diabetes. Insulin is normally produced when by the pancreas when blood glucose levels go up. That lets the cell use glucose to create glycogen. So we have two big things going on. We got glucagon and we got insulin. Glucagon gets released by the pancreas when glucose levels in the blood are low. Insulin is released by the pancreas, thank you. I was like, which one is it released by? When levels in the blood, when the sugar levels in the blood are too high. Between the two of them, they vacillate back and forth. So basically, glucagon is released when blood levels are low, so you haven't eaten in a while. You start to release some sugar, and then your blood sugar levels come up. As they get too high, insulin's released to bring them back down. And it keeps going back and forth until that wave gets smaller and smaller and smaller and evens out. It maintains homeostasis. Does that make sense? Basically, it's all about keeping things normal. Let's say you eat a big dinner. You eat something, I don't know, you eat a bunch of pasta. Pasta breaks down really, really easily into carbohydrates that you can use to make, that your cells can use for energy. So you get a big spike of sugar. Your body then says, okay, too much sugar, let's convert some of that into glycogen. So it begins to overproduce glucagon to turn, it begins to overproduce insulin to turn that glucose into glycogen. So your blood sugar level drops dramatically. Then suddenly you're like, oh, I don't have enough blood sugar. Start to release some of that sugar back as glucose. So the glucagon's produced and it brings your blood sugar back up. And then back down, back up, and back down. It keeps a wave that gets smaller and smaller and smaller until it evens out. That's how your body maintains its level of sugar. So example after example are seen in the body of hormones regulating different functions. They regulate all of your growth, like literally how big you get. Growth hormones produced in the anterior pituitary, and it grows the growth rate of bone and muscle. A friend of mine had cancer of the pituitary gland. He had it was a tumor. Basically, his pituitary gland was overproducing growth hormone. So what happened? What effect did he end up seeing? He got not just really tall, not tall and out. He got big, but it was all primarily muscle. What? Doesn't sound like a bad thing, except tumor in your brain kind of eventually wipes you out. It increases the rate of muscle mass. It increases the rate of bone growth constantly. In fact, growth hormone is one of those. They create synthetic growth hormone, or they'll extract growth hormone from people's blood in order to juice up athletes because it causes skeletal and muscle growth. Hormones will also cause behavioral changes. Short-term stress can lead your adrenal medulla to produce epinephrine. That triggers what's called the fight or flight response. Basically, your body has an inbuilt system that says, it's like an emergency system. It flicks on in order to tell you it's time to either get out of there or fight really hard. That epinephrine and norepinephrine increases your heart rate. So what does heart rate control? What does that do for you? Right? So as you're breathing, because it also increases breathing rate, you're bringing in more oxygen, you're pumping that oxygen faster, so your cells are getting super oxygenated, which means they're going to be able to produce a lot of energy really fast. Your blood pressure and glucose levels accelerate. So basically, you're setting your cells up to be able to produce a massive amount of energy for a very short amount of time. So again, I've probably experienced this. Let me tell you a quick story about mine. I distinctly remember I had this response, and it wasn't because I was fighting somebody. It was, well, sort of. I think I was at Busch Gardens a few years ago, and it was in the evening, and my wife had lost her phone. Somebody at some point had snagged her phone, and we didn't know where it was. So if you're missing your phone, you guys, I'm not sure if you have it. You have that like Find My Phone app. I clicked on the Find My Phone app, and it was still in the park. So suddenly I became like Detective Chris, going to go find the phone, get the phone back, because it's a $1,000 phone. So I leave my wife and kids and there with friends, and I go looking for this phone, tracking it down, doing the I'm getting closer, just constant refresh, constant refresh, constant refresh. So finally I got within 20 feet of the phone, and at this point my heart's beating. I'm like, there's somebody around here who's a thief who stole the phone. And I clicked the button to do the play audio, and whoever it was, they freaked out, because then I ended up finding the phone. It was jammed into a soda cup in the trash can. So I got it out. It's a fairly recent iPhone, a good case, so the soda didn't bother it. Pulled it out, and I was feeling good, right? My heart rate starts to slow down, but it was at that point I realized how tired I was, because I burned through so much sugar, and basically after this you start to shake as your body begins to try and get its hormone level or back to a homeostasis. I no longer needed all of the oxygen I was taking in, or I no longer needed all that sugar. So you come down from a high. and you crash hard. And I think you guys have felt that before at points in your life, right? Right? So, hormones are regulated through this negative feedback. And we went through a whole bunch of examples, but basically, you're going to produce a hormone in order to cause some effect to occur, and then as that effect peaks out, you need to drop the levels of whatever chemical is in your blood, so you end up, another hormone gets released to bring those levels back to stable. You have to maintain homeostasis.